Welcome to today's lesson. Today we're going to talk about an overview of perimeter, area, and volume of polygons. You've probably experienced all of these in the past, and we're going to tie past learning to what we're doing currently. So let's start with our first definition. A polygon is a flat, two-dimensional, 2D shape with straight sides that are fully closed and all the sides join up. So let's write polygon there. And the prefix poly means many, and the suffix means sides, so many sides. We also have solids called polyhedrons, and hedrons would mean many faces. So all polygons, specific polygons, have a prefix that tells us how many sides. For instance, a triangle would be a flat two-dimensional shape with straight sides, and it has three sides. Tri, the prefix tells us there's three sides. Quadrilaterals, quad, the prefix quad means four. Penta, the prefix penta means five, so pentagon is a five-sided polygon. Octagon is an eight-sided polygon. So specific polygons are given names so we can tell what kind of be aware of how many sides they have. Continuing, it says when calculating perimeter, area, and volume, many polygons have their own personalized formula. We can also use a general formula for most to help guide us. However, today we're going to focus on specific formulas using the square as an example. So let's look at perimeter first. Perimeter is one-dimensional, so let's circle that. It's just a linear or a line measurement, and we'll see that in just a minute. So one-dimensional. Perimeter is the total of the side lengths of the polygon. In other words, we're finding the distance around the polygon. When we work with the circle, the distance around the circle is called circumference. So perimeter is for polygons, P for perimeter, P for polygon, and circumference, which is the distance around a circle, C for circumference, C for circle, and we'll get into that later on during this unit. So let's start with this square. We're going to look at this square and we're just going to make up a measurement. Let's call this 3 centimeters. So we're going to say that this side is 3 centimeters. Now, it just said a few minutes ago that it's the total of all the side lengths. So I'm going to say, okay, I want to find the distance around the square. So I'm going to put big P for perimeter. That's what the distance around is. And I see a 3. Well, what do I know about this side? Well, it's a square, so it would also be 3 centimeters. This side would also be 3 centimeters. And this side would also be 3 centimeters. So I would write 3 plus 3 plus 3 plus 3. And so the perimeter, the distance around it, would be 12. And our unit of measure, what unit we use was centimeters, we'd write 12 centimeters. So what this would look like, if I drew it, I'd have 3 centimeters here for the first side, 3 centimeters here for the second side, 3 centimeters here for the third side, and then 3 centimeters here for the fourth side. So what would happen is I would have one linear or line to measure. So that's why they call it one-dimensional. But there is another way to find this, and some of you might have noticed this. Because the triangle has 4 sides and they're all the same measurement, we could have multiplied by 4. And because this is a formula, which means I can use it for all squares, I'm going to use side to mean, or S to mean side. So I could take 4 times any of the side measurements. Say that I have another square that was 7 centimeters long. Well, I put 4 times 7. So the S is going to represent the side length of any square. So formulas you don't have to use for perimeter. You can just add the sides together, but sometimes it's a nice shortcut. So let's prove that we get the same answer. If I took 4 times the side length of this square would be 3, I'm still going to get the perimeter as 12 centimeters. So you can use either way, whatever way you think best suits you. So now let's go on to area. Area is two-dimensional. So we're going to put 2D. Area is the number of square units inside a figure. Okay, so let's take the same square. We're going to say that we started with 3 centimeters. So I'm going to kind of mark them off. I'm eyeballing. So if I built a line inside and another line inside, so this is 1 centimeter, 2 centimeters, 3. And then I go to the other side, which is a square, so it has to be 3 centimeters. So I'd have 1 centimeter, 2 centimeters, and again, we're just doing this estimating. So if I connected those, oh, now I can see the square units inside. Perimeter's about adding up all the sides on the outside, and area is about the number of square units on the inside. So you may recall this formula for a square. The personalized formula for a square is to take the side times the side. And in this case, we have 3 times 3. And so according to this, the area should be 9. And we usually write centimeters squared, or you could write out the words or abbreviate square centimeters. You can write either one of those. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, sure enough, there are 9 centimeters. And this works for any square. We could also write this, and some of you might have noticed this, that because it's a square, both of these numbers, these sides, are always going to be the same. So we could say side to the second power, raised to the second power. Now that doesn't mean 2 times 3. If I wrote 2 times 3, it would have been 6. It means 3 times itself, 3 times 3. We're going to see 2 of the 3's being multiplied. So we mentioned earlier there's a generalized formula. And so by general, we have several different shapes. For instance, we have a square, we have a rectangle, we have a parallelogram. And if I wanted to find the area of any of those, including the square, instead of using side times side, I could have called it base times height. I could have called this the base and this the height. So those are the 2 dimensions you're going to use. This way and this way, a horizontal and a vertical. So let's continue on to volume. So it says volume is 3-dimensional, and volume is the number of cubic units inside. In fact, that one I pictured, that was going to be harder to draw, so I have pictures of it. So we're going to write 3-dimensional. You might have heard 3D before. So volume is 3D. And someone in class earlier today asked if we as people are 3D, and we are 3-dimensional. We're not flat, we have height. So if we look at this, if I looked at the top, okay, because I can't see the bottom right now, but I can see the top. The bottom underneath, what this cube is sitting on, is identical. It's just layers of this. So I can see that there's 3 cubes, 3 centimeters here. I can see that there's 3 centimeters here, and here's our new dimension. This now comes off the ground. This is the height. So this is also 3. The cube is very special because all of the side lengths are the same. So this time we're going to write V for volume. We had A for area, P for perimeter, and now it's V for volume. And we're going to multiply 3 times 3 times 3. And so when we do that, we're going to get 27 and centimeters cubed. There's 3 sides, 1, 2, 3, and we wrote a 2 when it was area, 2-dimensional. And so the volume, we could also write it as cubic centimeters. They write that sometimes. Volume also has what's called a mama formula or a general formula. So we could have worked with this. We would call big B, meaning the base that it sits on. It would sit on this. We would find the area of the base and then times the height. So we're basically finding the area, just like we did up here, and then multiplying times the height, one more dimension. All right, last figure. You may have noticed this looks different, and this is different. This is a cube. All sides are the same. This is a rectangular prism. And it might look like a box. Somebody called it a box in class, and so it is a box, but we refer to it in math as a rectangular prism. So we're now going to look at the top. If we do the top again, if I look at this, this is exactly the same thing as it's sitting on. If I imagine going down 2 layers, it would look exactly the same as I see. And so I see 4, we'll call those centimeters, and then I see 1, 2, 3 centimeters, and here's our new dimension. And it doesn't matter which one of these I choose. I could write a height here, or I could choose to draw the height here, or I could choose to draw the height here. So I wrote it on this side, so I'm going to put 2. I see a height of 2 centimeters. So volume for my rectangular prism, remember it's 3-dimensional, so I'm going to write 3 numbers. It would be 4 times 3 times 2. And so the volume, 4 times 3 is 12, 12 times 2 is 24, and we would write centimeters cubed to the 3rd power, our cubic centimeters. Now, let's look at this mama formula again. If I chose to do the mama formula, the base, I'm looking for the area of the base. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 cubes here times the height. So this would be 12 times the height, and I'm still going to get that 24. So thanks for listening, and have a great day.